Hi viewers, welcome back to our channel Light to Crack Math. In our previous video, we had seen about the addition, subtraction, multiplication and division of integers. In today's video, we're going to see the properties of addition, subtraction, multiplication and division of integers. If you are a first time viewer of our channel, then do subscribe our channel without fail. And click on the bell button to receive future notifications of our video. So first, we'll be looking into the properties of addition of integers. So the first property is the closure property. So the closure property states that when two integers are added, the sum is also an integer. For example, I'm taking an example of plus 5 plus minus 3. So it is nothing but 5 plus into minus is minus and 3 and 2. So you can see 2 is also an integer. So I take another example, minus 5 plus 3. So when the signs are different, then we are supposed to just subtract. So 5 minus 3 is 2 and write the sign of the greatest number. So minus. So minus 2 is also an integer. The second property is commutative property. So commutative property states that when two integers are added and the order of the addends are interchanged, the sum remains the same. So in simple words, what you can tell is A plus B is equal to B plus A. So we'll see this with an example where our A is equal to 5 and our B is equal to 3. Okay, so now when we have 5 plus 3, the answer is 8. So if you are going to have 3 plus 5, there also the answer is 8. So commutative property holds good for addition of integers. So the third property is associative property. So the associative property states that if A, B and C are integers, A plus B plus C equal to A plus B plus C. That is, even if the order of the groups are interchanged, the sum remains the same. Okay, so we'll check it out with an example. So let our A be equal to minus 2, our B be equal to minus 5 and our C be equal to minus 3. Okay, so now we are going to check the left hand side, that is A plus B plus C. So this is nothing but minus 2 plus minus 5 plus minus 3. So now you have minus 2, you have plus into minus, that is minus, and 5. Again you have one more plus into minus, so that is also minus 3. So both the signs are the same, so you will have to add and just write the common sign, so minus sign in front, minus 3. So when two integers are like integers, that is they have the same sign, then we will have to simply add them and put the common sign in front. So it is minus 10. So we have now found out what is our LHS. Let us see if we are going to solve for our RHS also, if we get the same answer. Okay, so here we will be writing it as minus 2 plus minus 5 plus minus 3. So again you have minus 2 plus your minus 5 remains the same, but here plus into minus is minus, so you get minus 3. Then you have minus 2 plus, so here you have like integers, both are having the same sign, so when you add you get 8 and you put the sign in front, so it is minus 8. Right, so now this plus into minus is minus, right? So you have minus 2 minus 8. So now your sign are the same, so you will have to just add and put your sign in front. So you can see both your left hand side and right hand side you've got the same answer. So associative property for addition of integers also holds good. So now we'll move on to the fourth property, that is additive property. So when 0 is added to any integer or any integer is added to 0, we get the same integer. When 0 is added to any integer or any integer is added to 0, we get the same integer. So since additive property holds good for addition of integers, 0 is called the additive identity for integers. So let's see an example. If suppose we have minus 5 plus 0, then our answer is minus 5. Or if suppose you're going to have 0 plus minus 5, then you have plus into minus to be minus, and 0 minus 5 is again minus 5. Okay. So now we are going to see the property of subtraction of integers. So the first property and the only property which is there for subtraction of integers is the closure property. So if two integers a and b are subtracted, the difference is an integer. So let's check out an example. We are having 9 minus 3. Then we have it as 9 plus 3, which is equal to 12, which is again an integer. So we'll check another example, 9 minus 3. So then we have got 6, and that is also an integer. Alright. So closure property holds good for subtraction of integers, and none of the other properties like commutative property, associative property or identity property holds good for subtraction. Okay, so none of the other properties holds good for subtraction. So now we'll just move on with the properties of multiplication of integers. So the very first property of multiplication of integer is the closure property. That is, if two integers a and b are multiplied, then the product of the integers is also an integer. So let's check it out with an example. Suppose we have minus 5 into 10, then we have the answer to be, that is the product to be minus 20. If suppose we have minus 5 into minus 4, then our product is again plus 20. If suppose we have 20 into 3, then you have 60. That is also an integer. So any two integers, when it is multiplied, the product also remains to be an integer. Therefore closure property holds good for multiplication of integers. The second property is commutative property. That is nothing but a into b equal to b into a. So let's check it out with an example of a equal to minus 2 and b equal to 15. Okay, so first we'll solve it for our LHS. Our LHS is nothing but a into b. So that is nothing but minus 2 into 15. So here we have got minus into plus, which will be minus. So 2 into 15 is 30. So our product is minus 30. So now let's check it out for our RHS. So our RHS is nothing but b into a. So that is nothing but 15 into minus 2. So again you have plus into minus, which is minus, 15 into 2, which is 30. Okay, so from this you can see that your LHS is equal to RHS, which means a into b is equal to b into a. Okay, so now we'll see the next property. Property 3 is associative property. So associative property states that for any integer, a into b into c is equal to a into b into c. Okay, so we'll check this also with an example of a equal to minus 1, b equal to 2 and c equal to minus 3. So first let us check the LHS. So our LHS is nothing but a into b into c. Our a is minus 1 and b is 2 and c is minus 3. So minus 1 into 2 is minus 2 and we have our into minus 3 here. So now minus 2 into minus 3 is plus 6. So this is our LHS, and now let's check for our RHS. So our RHS, we have A into B into C. So our A is nothing but -1, B is 2, and C is -3. So -1 we write it as such. 2 into -3 is -6. -1 into -6 is +6. So our LHS is equal to our RHS, which means associative property for integers holds good. Okay, so now let's move on to the next property, that is multiplication by 0. For any integer A, if you're going to multiply it by 0, or if 0 is multiplied by any integer, then the product you're going to get is going to be 0 always. For example, if it's going to be 5 into 0 or 0 into 5, then the product is 0. Or if it is going to be -208 into 0 or 0 into -208, then again the product is going to be 0. So the next property is multiplicative identity. So multiplicative identity is nothing but 1 into A or A into 1 is equal to A. That is, when you multiply an integer by 1, or if 1 is being multiplied by any integer, you get the product to be the integer itself. Okay, for example, if it's going to be 1 into -5 or -5 into 1, then you get back the same integer -5 as the product. Or if it's going to be 1 into 123 or 123 into 1, then again you get back the same integer 123. So this is called the multiplicative identity for integers. Okay, so then the next property is distributive property of multiplication over addition. So distributive property of multiplication over addition states that A into B plus C equal to A into B plus A into C. So now let us check this with an example where your A is going to be 1, B is going to be -2, and your C is going to be 3. Okay, so first let us check our LHS. So our LHS is nothing but A into B plus C, right? So that is 1 into -2 plus 3. So -2 plus 3 is 1. So 1 into 1 is 1. Moving into RHS, we have got A into B plus A into C, right? So our A into B is nothing but 1 into -2 plus 1 into 3. 1 into -2 is -2. 1 into 3 is 3. So when you have -2 plus 1, the answer is 1. So our LHS is equal to RHS, which proves our distributive property of multiplication over addition holds good. Okay, so a similar property is distributive property of multiplication over subtraction. Okay, so let's check it out. For A equal to -1, B equal to -2, and C equal to -3. Okay, so let's start with our LHS. So our LHS is A into B minus C. So A is nothing but -1 into -2 minus of -3. So it's -1 into -2. Minus into minus is plus, so +3. So -1 into -2 plus 3 is 1. So -1 into 1 is -1. So moving on to RHS, we have A into B minus A into C. Okay, so our A is -1 into 2 is our B, minus 1 into minus 3. So minus 1 into minus 2 is 2, minus 1 into minus 3 is 3. So 2 minus 3 is minus 1. So our LHS is equal to our RHS. So these are the properties of multiplication of integers. So far we have seen the properties of multiplication of addition, subtraction and multiplication, and now we will be moving on to the properties of division of integers. The first property of division of integers is the closure property. So for any two integers a and b, if you are going to divide a and b and get a quotient considered to be c, then the quotient c is also an integer always. Okay, so for example, minus 5 divided by 1 is again minus 5, and 25 divided by 5 is 5, which is again an integer. So closure property holds good for division of integers. So our next property is property of 1. So a divided by 1 is equal to a. That is, when you divide a number by 1, you get back the same number. So you can call this as division identity of integers as well. Okay, so if it's going to be minus 23 by 1, then you get back minus 23. If it's going to be 145 divided by 1, then again you get back 145. Okay, so this is about the property of 1. So the final property is property of 0. So if you're going to, if 0 is being divided by a, so the final property is property of 0. When 0 is divided by any integer, then you get back 0 as the quotient. Okay, but you should remember that any number divided by 0 is not defined. Okay, so now let's see the example for 0 property. Suppose 0 is being divided by minus 2, then that is going to be 0. If 0 is going to be divided by 500, then again you get the quotient to be 0. So with this, we come to the end of today's video. If the video was informative, then do like our video and share about our channel to your friends so that they get the light to crack their math.